This day number 1 is specially themed to OpenMBE, and it's my pleasure to welcome Robert Karban and Chris Delp, who are kind of co-chairing this day, and also welcome to Nancy Laramie from Ivado, who is she is a co-chair of Models 2020 Industry Days. Today, we're going to have altogether 11 talks as part of the OpenMBE Day. First, Robert Karban and Chris Delp will give a general welcome and introduction to OpenMBE, and then Enrique Krajmalnik will deliver a keynote talk on the OpenMBE community as let's say the industry driver, and this is going to be a first session, after which we restart at 11 a.m. Montreal time. And by this, I will stop sharing and hand over the virtual microphone to Robert. Robert, I think you can start sharing on your part. And I start muting. Yeah, Robert, I think it's yours.
Can you hear me? Can you hear me?
Yes, great.
Okay, good. Okay, thank you very much for the welcome. I'm quite excited, and the OpenMBE leadership and community in general, that we made it to the Models Conference. There was quite some work and also support from the Models people, and including you, Daniel, and Jürgen Dingel also, who I want to mention, who helped us to get the OpenMBE workshop going yesterday, which I think went very well. So let me start with a quick overview of who we are, and then we'll talk about the background, what our motivation is and why we're doing the things that we're doing. So the OpenMBE is a community for open source modeling software and models. It was created out of established out of the need of several organizations to create a model-based engineering environment to deal with the challenges of building complex systems and help with the transformation of system engineering into a model-based paradigm. It started with some core software that JPL released a few years back and has been growing since then. People start to contribute, adopt it, and we have quite a number of participants and adopters now in that community. We're counting more than 400 members, and it's very practitioner driven. There's a lot of industry, there's also some academia, and I think the goal to participate in the models is to bring 3 communities together: the practitioners in industry on one side that have the requirements and the needs, academia, the rich academic environment, and the community of the models, where there's a lot of brain power that could help us to find solutions, and the vendors who can commercialize it, so we can in the end buy those products. So that is somehow the goal or the vision that we have with this participation in the models. But where did it all start? So Chris, you want to talk about that first few slides?
Sure. So yeah, and Robert and I worked together on this in various ways, going back to INCOSE Symposium in Singapore, which I don't even remember the year, but
2009.
There we go, 2009. You're about my truck. So systems engineers are the key focus of this environment, and focusing on what they do. And today at JPL and other places, systems are complex, and there's ever more collaboration associated with building them. And systems engineers in particular are tied up in this because of its interdisciplinary nature. So systems engineers have the ability to do their own system level designs thanks to MBSE, but they also have that compels them even more to collaborate with the other disciplines in engineering to build these modern complex technical systems. So that requires leadership, architecture, design, and the management of complexity. So it's a lot of things to bring together. And these days teams are quite large. So this is a picture. Is this still Cassini, Robert, or did we?
That's still Cassini. Yeah.
Okay, so this is the picture of Cassini. We're going to update this slide shortly with a picture of the Mars 2020 team, which is even bigger, if you can believe it. But that's a lot of people to work together and build what in this case was the exploration vehicle for Saturn, and what most recently is the most sophisticated rover yet that will shortly be on the surface of Mars. So all these people have to talk and communicate and bring all their pieces together into a system that works. So
can you tell the story about the memos in Cassini?
Oh, yes, right. So Cassini has, sorry, Robert will have to cue me a little bit. It's 6 o'clock at LA. So yeah, so in the days of Cassini, we didn't have the internet. It was built in the 90s. Well, the internet was pretty new, and doing engineering with software was pretty new. So on Cassini, they had this conventional document system where when there was a new change to decided about the system, the technical authority would issue a memo via typewriter and interoffice mail. And there was an army of people with typewriters and everything that would take these memos, and they would read through all the documentation and impact the changes and publish new volumes and distribute them to everybody. So the information creation cost was expensive. And there was this team of people whose job it was to make sure that the information was correct. And since then, obviously that's changed. It's now quite cheap to circulate an Excel spreadsheet or a Word document or a PowerPoint deck with lots of rich technical information, but we no longer have this group of people that impacts it and ensures that everybody gets the same copy in the same way. It's much harder to do because of the cost of information. So today a project starts simple. There's a few documents and most notably a few people, and people iterate on their models, and the material starts to grow, and more people are added to the team, and more documents are created, and more people are added, and more models are created, and the information itself starts to become complicated. And before you know it, it's an overwhelming number of people and documents. And now if you're this little meeple in the middle and you just joined the team, it can be quite difficult to figure out what's going on and where everything is and what you need to know, and if you have the right email from so-and-so and such and such. So yeah, this was the situation that we faced.
Exactly. I mean, and the main product of system engineers are still documents. There is engineering work involved, but the documents are the primary artifact that is delivered. Especially
in the United States government. Most of my job is data entry, right? These are, so we for modern engineers coming out of school too, they don't want to spend their time docu-jockeying and PowerPoint ranging and accelerating. They want to do real engineering work. They want to have a meaningful impact on the system, and they've been taught all of these modern skills in CAD tools and Python and MBSE and SysML and stuff like that. They want to use those skills. So that's another aspect to consider in this as well. So these are kind of some quasi classifications of real engineering versus overhead. And I think Robert and I would argue that the organization's best use of their talent isn't doing this stuff, right? Repetitive data entry, version confusion, constant searching. These aren't the tasks that we want to be paying our engineering talent to spend their time on. I mean, some of it is unavoidable, but there's a quotient that develops here that starts to make it unreasonable. So a better way is to take this mess and reorganize it into something that's congruent around a sane process for managing the information, which allows software to maintain all of this interactivity, and in particular, the relationships between these things, so that it's a body of information that still produces the documents and the products that people expect, but instead is searchable and navigable, and you can understand that impact the way the memos from Cassini worked.
Yeah, we want to shift away from an email culture, which is still kind of dominant. People send around the Excel sheets, right? We want to shift to an authoritative source, single source unified resource, right? But the information is connected within and between those documents with the engineering work, right? So you have the typical situation where you perform some engineering task, you have your engineering model, for example, and then you copy paste it into some document, and then you lose the connection immediately. And as it moves on, this disconnect becomes bigger and bigger because you start to copy paste stuff. So we want to bridge this gap between the engineering work and all the company documentation which is created. Chris?
So this illustration is intended to convey the concept around the user experience that we want to convey with OpenMBE. So this update once, use everywhere notion, where this individual who's maybe working on their actual like their physical model of the spacecraft, and this individual is working on maybe their SysML model, and possibly most importantly, this individual who's working on a document description of some aspect of the system that they have to deliver as part of a gate product, are all referencing the same information. So there's no, the other two people in the equation may not even realize that when an update comes their way, the engineer that made that update was in a different tool when they did it. So the OpenMBE stack, if you will, is made up of some key pieces. And at this point too, we introduced not only the idea of a software platform that can do these things, but the idea that as a companion to that, we should be practicing open source practices in the model-based engineering world. So we have the model management system, which is the core repository that manages the federation of references and so forth. We have the view editor, a model and platform for model analysis, which is the document-based interface with this companion based on Jenkins that allows you to run analyses and executions behind your document to do some of the updates. And the model development kits, which is really the integration strategy for how we integrate various commercial and open source engineering tools into this environment. So we have several MDKs you can see on the website. We have a DoorsNG MDK, a MagicDraw MDK, MATLAB,
Mathematica, Python.
Yeah. So, and then we have a component of documentation and training, and then the Robert's 30-meter telescope model that he open sourced, and the cookbooks, which really bring into the idea that with an open source community, the future is not just having this platform where we can share this information, but that engineers can start with vetted, well thought out models and libraries, and benefit from open source practices the way software developers benefit. So we connect up this platform in this representative way to see that the model management system can act as the gateway for the authoritative source. You have MDKs where different engineering modeling is taking place, and view editor for consumption of those models in the traditional styles that they're used to. And then as an example, you can load in the 30-meter telescope, and you can load in the cookbooks and have a full functioning environment for doing engineering modeling. So Robert will do a demo now.
Yeah. So the little demo is a simple example where you have the authoritative source of your engineering model. You have one flight system engineer that has to analyze the MEL, as we call it, which is the key product in for spacecrafts, and an SME, the subject matter expert, that has to create a document, a report on that MEL. So here's the video, and I'll comment while we go along. So what you see here is what we call the view editor, and the view editor basically is a view and viewpoint oriented projection of the system model, which can come from different sources. As Chris mentioned, MMS has federated cross references, but basically you work on a document, so that's the natural environment for many system engineers, but it's hooked up at the back end with the model. So whenever you change something on there, it will actually change the model, but it lowers the barrier of access for many people. Many people will never open the modeling tool and draw some diagrams. They have their tables, which are the beloved tables, like this one, where we have a list of the equipment with a mass and some properties, and we're starting to change that on that web application. And as soon as we save, it goes back to the model. So that one person changes it on one side, and it goes back to the model. On the other side, we have another integration. In this case, it's MIPLE MVSE that you will see later on. There's a talk about it. But you update the model and in Excel, and it refers to the same data. And Excel is another tool that system engineers like, right? So, and then they would add another component by simply inserting a row. And when they are doing it, the tooling takes care that it conforms to the modeling structure behind. Would do a commit, which again updates the model, and on the other side, the document would be updated, so there is an additional row. So that's a very simple example, but that somehow shows you how it works. You have MMS in the middle, and a number of applications that can access, modify, author, analyze that data that is available. So the OpenMB, as mentioned before, has started some years back and has grown into a rich community of adapters and contributors across various disciplines. So you see NASA and their projects where it has been used, science and engineering, the 30-meter telescope was mentioned, where I worked with a team to produce a completely model-driven engineering documents. Industry has adopted it, most notably Boeing, Ford, and Lockheed. It has been used for developing the SysML-v2 standard with OMG and in COSY. And also, and that is very important, vendors have picked it up and built integrations for it. So we give a short, brief history of where we started. The first big project was Europa Clipper, where OpenMB core software has been used. And there have been about 100 concurrent users to produce more than 230 documents. But the most important number is there's 445,000 connections between those documents and the model. And what all these connections that used to be implicit, right? You have all these documents and they are somehow connected. You don't know if a number is the same number in one document versus another, but now they are explicit, or at least many of them. Of course, there are some which are still there because that's a process, but the number tells you what kind of complexity we are dealing with here, right? Chris has a very brief story on one anecdote from that project. So maybe Chris, you can tell that in a few seconds.
Sure. So when I was on Europa Clipper early on, there was an event where it was a fairly minor event. There was a document that needed to be produced for an independent cost evaluation of the project, and it had somehow not gotten done and not gotten started early enough, and so it was a bit of an issue with the project, how to get it started and get it completed as quickly as possible. And it was the kind of thing, it was a kind of a comprehensive description of our understanding of the mission at the time. So it would have taken several people to get together and bring all their spreadsheets and documents together and sort everything out. It probably would have taken a week just to figure out who had to put what where, and then they would have had to stitch it all together and everything. And the modeling team generated it in 4 hours. And not only was it generated in 4 hours and correct, it was mutually consistent with all of the other documents that the project was managing out of OpenMBE at the time. So those benefits were quickly realized in a pinch. And that was the only time the project manager ever smiled at me. So we were walking down the hall.
So at that time, so for Clipper, it was the impact was a reduction of overhead to manage all this data. There's some quotes from flight system engineer. I'll skip over them in the interest of time. The next step it took was with Mars 2020, that is currently on its way to Mars. And there, the impact was on the technical rigor. So 50 concurrent users, 90 documents, 180,000 connections, and with the emphasis of precise engineering documents that is also integrated with the subsystem. So like reference designators, electrical function list, and functional block diagrams. But so another interesting thing is the international standards. So the OMG has been producing modeling specifications for modeling languages and other things for decades with Visio and PowerPoint. Surprisingly, but with SysML 1.5 and SysML v2, we finally have reached the step where we can generate that documentation, right? So the whole SysML v2 and SysML 1 specification is model based and generated using the OpenMB core software. And there's quite a number, I think there's more than 60 organizations, meanwhile, tens of contributors and hundreds of consumers. And the interesting thing there is because we know it's model based, we have a much better idea also what the connections between those elements mean. So there are 6 documents produced at the moment. But would it scale was the question, right? Because you have many systems that do similar things, but would it scale? And Boeing and Lockheed showed us that it does. So Boeing adopted it and had some time ago around 1,000 concurrent users across 50 programs, and Lockheed with 100 users and across 50 projects. So the demonstrated enterprise scalability is a key element in this effort. But would it work also across organizations? And Stevens did a very good case study, and Mark Blackburn will talk about that later today, together with Naver to demonstrate how OpenMB can be used for acquisition and interorganizational collaboration with sign-offs and producing CDRLs and DIDs, be using View Editor again and MMS. So, Chris, you want to talk about the vision?
Yeah. So today we can see that there are cases where people are using OpenMB to gain this experience between this information within their organization, the so-called intra-organization. But the vision is that we could take things beyond that and go to this inter-organizational concept. So leveraging on the internet and open source practices, there could be a future where we could connect these deployments of OpenMBE directly between these different organizations. So this is the concept we're trying to employ for Mars sample return, where people will be able to connect between their different deployments and connect this information so that stuff that's being built for different parts of the mission can still be connected and interoperated across greater distances, with this global vision that one day we'll be able to connect across this entire fabric of models and cross references, so that perhaps everybody will be referencing the SysML specification itself and other modeling language specifications in a hosted way, and deploying them across their different environments and using different model libraries, and being able to develop this seamless collaborative fabric of interactivity, even better than what open source software enjoys today.
Right. So this global engineering ecosystem vision is somehow comparable with the web. I worked at CERN in 1990 when the very first web server went online. I was there when the internet was invented. And with OpenMV, I hope to be in a similar position when the global engineering system was invented. So we also have some recent updates. So we have become very recently a NumFocus sponsored project together. So NumFocus is the organization that hosts, for example, Project Jupyter, which is also a key element in our MBE strategy together with SysML v2. And maybe interesting there for the academic community is that you can also apply for funding if you want to develop anything for OpenMBE, and then it will be looked at. And I think that's where we end, and almost on time, actually exactly on time, I believe. So that's OpenMBE background.
Thanks a lot, Robert. And I probably suggest that unless I see a long list of questions in the chat, which I don't, and at the same time I'm announcing that to the remote audience that you can ask questions to the speakers in the chat, which will be checked by them at some stage, and I will also read that aloud. So unless we have a long list of questions, I suggest that we switch over to Enrique Krajmalnik, who is our keynote speaker today for the OpenMBE Day. And it's really my pleasure to welcome Enrique, who has recently, very recently changed jobs, and as far as I know, he is now with Zuken. But I expect that you tell a bit more about also your past involvement with Dassault Systems and Magic Draw and the like. So Enrique, I think the floor is yours.
All right, thank you very much, Daniel. Just want to validate that everyone can see my screen. All right. Okay, good, thank you. So yeah, good morning, everyone. It is really a pleasure to be here. You know, especially in the OpenMBE track. I have a little bit of a history with OpenMBE, and I have to admit that this is my first presentation at a virtual event. And it is really nice to be sitting here, you know, in the comfort and safety of my home office, where absolutely nobody can tell that I am not wearing any shoes. So at any rate, as Daniel indicated, some of you may know me or have met me in the past from the 6 years I spent at NoMagic, which was subsequently acquired by Dassault Systems. I was the CTO at NoMagic during what I would call, you know, kind of the increase and explosive growth in MBSE adoption over the last 4 years. And as Daniel mentioned, I have changed roles. Approximately 6 weeks ago, I decided to take on a new challenge, and I am now working in the role of Vice President of Business Development at Zuken USA. So slightly, different market, but very much still the same goals of trying to develop these more integrated, open, and connected digital engineering environments where we can reduce that burden that exists today, not only in the context of document preparation, but also in the context of transitioning from that core systems engineering work that is so important to manage complex products to that detailed design work that's done in products like what exists in the Zuken portfolio. So I do want to preface my presentation by telling you that what I am going to be discussing today is my own personal account. I am not representing any company here, not NoMagic, not Dassault Systems, not any of the organizations that I'm going to mention in my presentation. This is my own experience and my own opinions over the last 25 plus years of my career. And the good news is that I will only subject you to my opinions for about 40 or 45 minutes, and hopefully leave some time for questions for both myself as well as the team from JPL. So I am here to tell you guys a story, and it's a story that all of us probably know quite well in the sense that it's a common challenge for people who are developing software or systems in general, right? We struggle to identify the proper needs and the proper requirements. Software companies in particular, we want to build better mousetraps. We want to build products that our customers love and that they use. We want to be, a love brand for our customers. And sometimes, unfortunately, what we hear is that, companies use our software because it sucks less than the other software on the market. Kind of sounds like the presidential election, I know, but that's kind of the case. And I think that's especially true in engineering software just because of the complexity of what we are trying to address with engineering software. But the truth is that we do want to build killer products, but how do we do that? How do we ensure that we get the right features, the right interface, the right use cases? And how do we ensure that the intended use and the actual use are not so disparate that the fundamental approach we took to designing our software, breaks in practice? And at the end of the day, we want to ensure that customers use our products because it makes their jobs easier and better, and it makes them more efficient. And that's the goal. That's what we all want to accomplish. And typically, to do that, we engage in this process of ideation, followed by some kind of bare bones version of a feature or a capability that we think might make sense. We engage with a couple of customers to get additional input and ideas, and we use that to confirm that the idea is marketable. In some cases, we'll do a deeper analysis and maybe engage with a few more customers. And eventually, the goal is to deliver a specification to the development teams, at which point we work through whatever process we have in our organization, be it waterfall or agile, and eventually come up with something that we get in the hands of the users. And I'm referring to something that we get in the hands of a user before general availability or a release. And in some cases, this is done almost at the very end of the process before final delivery of a general release. In other cases, it's done earlier in the process, and it's done often in an iterative way. But no matter the approach that software companies have used, there are challenges along every step of the way, and they often prevent us from delivering what customers need or want. And if you've developed anything in the past, you know how difficult it is to do that when you have a small community of users. But how do you build something that you want to be adopted by tens, if not hundreds of thousands of users? Well, one way is you hire a team of awesome analysts and you have a process with many customer touch points. but that takes a lot of time to properly understand the need. And few companies, and there are some, but few companies really do this well. So the processes we have in place today don't really work particularly well. It's really common nowadays in many companies to build, minimum viable products, these MVPs, so to speak. And we build those as a means to determine if we hit the mark with our initial requirements elicitation and analysis efforts. But the problem is that MVPs are typically insufficient to get a good read on the need or how well that solution aligns with the need. And the reality is that they're often developed with really small, minimal teams. And the reason for this is a pure business decision. It's a cost-benefit analysis. Dip your toe in the water, see what the reaction is. So these small teams are used to build these MVPs to see if there's enough interest in what's being built. But unfortunately, that MVP doesn't gain enough traction because it's an underdeveloped product, and oftentimes it's underdeveloped because it's understaffed, and it's a vicious cycle that happens inside of many software companies. So, whether an MVP should ever be released to the public is a different topic for discussion, but the reality is that these MVPs are released as general products more often than you think. So many times we deliver betas. We're all familiar with the beta process, and betas, unfortunately, are often too late in the process and in the evaluation cycle to really elicit enough meaningful feedback. And typically what happens is you get feedback from a few highly motivated customers, but it's typically not diverse enough from a broader cross-section of the user community. We use early releases, but they're often off base and require several iterations to deliver anything beyond features that are so primitive that they don't really provide enough surface area for testing. And the other extreme is to get so deeply involved with your customers that you expose nightly builds to them. This is really a big challenge. It's hard to track, it's difficult to implement, and almost impossible to manage effectively. And by the time you get feedback on a particular build, it could be weeks or months old. So all of these suffer from the fact that there are varying degrees of engagement, and typically in all of these approaches, you only get a handful of customers, and even from within those customers, you're only getting input from very few, as I mentioned, highly motivated users. You're not getting a feel for the impact even across an organization. And what happens is your products run the risk of being so narrowly defined by those users that they don't really meet the needs of the market, and they end up being nothing more than expensive custom development projects for the software vendor, because we're really only building products that satisfy the feature requests of those highly motivated influencing users. But is there a better way to engage? Is there a better way to align the end user, the company for which they work, and the software vendor with these complementary goals? And the truth is that we do have complementary goals. End users want software that makes their lives easier, better. They want software that they enjoy using, or at least doesn't suck. Software vendors want to make money, with the software that they're providing. The companies want to see a return on the investment in that software. And if you can align all of that, that's a successful relationship. So at the end of the day, what would happen in that type of environment is where everyone is aligned, is that software companies would be able to bring features and capabilities to market quicker, accelerating that development lifecycle and bringing more value to the customers they serve. And is there a way to do this? Well, the beginnings of a possible answer to that began I think it was the summer of 2015, if I remember correctly, and it was at the technical meeting of OMG. I was pretty new in my role, having just taken over the R&D responsibility and the R&D efforts at NoMagic about 2 to 3 months prior. And I was asked by the account rep at NoMagic to meet with a guy from JPL who wanted to discuss some of the stuff they were doing. And, you know, I'm always happy to meet with customers, so I agreed. So there I am, you know, with the account rep. We're sitting in the coffee shop at the hotel, and I see this foreboding figure walking over towards me, you know, wearing shorts, a skater t-shirt, and Vans sneakers. And we all know that, oops, wrong delp, sorry. There we go, that's Chris. Don't let the button-down shirt fool you. He's almost always wearing t-shirts, and we all caught a glimpse of that a little while ago. But at any rate, Chris wanted to show me this thing called View Editor. And he described it as this web-based collaboration platform that presented models and as documents for non-modelers. And he went on to describe how important this was to bring the non-SysML community into the model. And you got to remember, this was, you know, 5 years ago. So, you know, the state of a company like NoMagic was a little different 5 years ago. The state of the industry was different 5 years ago. And, you know, Chris really made it a point to not just talk about the technology that they were using behind this, but how they were using it. So, you know, after having a couple of conversations around this, we decided that it was time to get together, see a demo, and see what this was all about. So, you know, I went back to my company to talk with my boss, and, you know, at first there was a lot of resistance to this, and not just for management. There was a lot of resistance internally. I'm sure you can imagine that within a software company, when you see a customer building something that you don't have, it's challenging, it's a threat. And how do you overcome this? You know, the questions were flying around, you know, why aren't we already building this? Why are they ahead of us? And you know, are they going to go into competition with us? What does Chris really want to do? You know, so these are all questions that came up at the time, and they're not simple challenges, and they came from many parts of the company. But interestingly, it was R&D, you know, my team, that was probably the most interested in really seeing what Chris and the JPL team were doing and what they were working on. But this was by no means a done deal internally. So we really had to work on overcoming those perceived threats, you know, in the company. And, you know, like I said, it's not an easy task in any organization. But, you know, we went ahead and moved forward with some initial meetings, and there, you know, there it was. Chris was showing us View Editor, and it looked a little different than the screenshot I'm showing right now at the time, but it was exactly what Chris described. Here was this, you know, model data being presented in a wiki-like format in a web browser. You know, he talked to me about MMS and the REST API, and, you know, was it the product or the technology itself that excited me? Well, there was definitely some interest in seeing this, because, you know, one of the initiatives that we wanted to undertake was starting to move some of our capabilities to the web. So there was definitely interest in seeing this. But what really intrigued me was, you know, the potential for a different way of doing business, right? A different way of engaging with the customers. Could this be some sort of model or roadmap for us in the future? And that's what I really wanted to find out. You know, this is how I pitched it internally, right? So, and essentially what I did is you know, present this case to ownership as a way of engaging more intimately, for lack of a better term, with one of our customers that had a large user community that was really pushing our technology. And I had to focus on the value of the R&D that was being done within this community and how it could accelerate our efforts with really, you know, not a significant increase, if any, to our costs. So, you know, it took time, but we finally got the green light to move forward. And it wasn't easy, you know, at the time. And I don't know if anyone here remembers a product that was, yeah, I think it was the focus of the NoMagic World Symposium back in like 2014, 2015. It was called the Cameo E2E Bridge. And it was a third-party product that, you know, back in that time frame, 2014, 2015, was seen as a way to move Cameo into being an enterprise player. It was a model-based, model-driven middleware product. but there were some problems with that. It was a third-party product, right? And the impact that had on our own internal efforts, I don't think that was contemplated at the time that decision was made. It was not a very strong message to give to R&D that it was not their efforts that were going to lead to the growth of the company. So we were in the middle of correcting that mistake. We were focusing the company on MBSE, and we needed to make sure that this engagement with JPL and OpenMBE did not put that at risk. So we needed our R&D to know that we were still 110% behind them, and this was by no means a way of saying, look, there's someone doing something better than we are. The approach was, let's see what we can learn and work together to make our products better. So Chris, your timing was horrible, but I would argue that we pulled it off. At the end of the day, we really did pull it off. So as we engaged and learned more about what JPL was working on, it was really clear that this was not aimed at becoming a commercial application. This was a community of users, initially, only at JPL, but they wanted to use the data in the models in a way that, we had not thought of or had not thought of fully in its entirety. We hadn't really, gotten our heads outside of the Java client and the hardcore modeling. And part of this impetus in JPL was a reluctance to change internally by some groups of users, right? I mean, we all see that, as Robert and Chris mentioned. You had users who love their Excel, and part of it was this desire to modernize and democratize these new technologies and things that these younger engineers were wanting to use because they learned it in school. And this is a different world now in terms of applications and technology. And a big part of it, I think, was also that need to bring in more data and more users into the modeling realm in a way that did not require the learning curve of a new notation. So in any case, the key message is that the need was real, and this community was sharing the needs internally, where they had this team of developers that were, building inside of their environment to provide solutions to those use cases that commercial companies weren't addressing at the time. And what was really cool when we engaged is that, here we are, this software company. And what we've always wanted as a software company really is a dedicated focus group. And that's essentially what this community was. And, it was a broad spectrum of users inside of JPL focused on using, the software to make their lives better and working with their teams internally. And it was a really interesting dynamic to get that constant feedback and to see, what the use cases were, the feedback on the use cases, the implementation, the UI design. And what was interesting about this was, I didn't have to spin up a ton of VMs in Amazon, for testing where there was no human factor to it. We were seeing real human feedback to the solutions that were being built internally at this community. I didn't have to go through these processes of legal reviews on, it was just this really nice, open relationship. And without the overhead that happens in typical processes, no need to track, builds, licenses, keys, expiration dates. All we had to do was participate and collaborate and listen and learn. So as I said, the first realization was this was not competition. It was very much about working together. Here was this research institution, right, whose mission it is to advance the national interest, taking our tools and pushing them to their limits to see what was possible. I would say that, JPL in many regards was at the bleeding edge of MBSE. And, let's be fair, sometimes successfully, sometimes not as successful, but, and that's no knock, by the way. But what was interesting is that they were doing what, we as software developers wish we had time and the resources and money to do, which is to sit in a live environment with our users and really, alongside them, see how they're using it, see what the reaction is to new capabilities, listen to them and learn. But this was more than just pushing the technology. It was about pushing it in the context of those real user demands, those questions about what if, were being answered internally by this community of practitioners. And then they shared it with us. They showed us what they were doing. They showed us what users wanted, but they also showed us what was possible. They brought us into this community and made us a part of it. And viewed properly, this community, was really an extension of our R&D. So what was the experience like as, we engaged with View Editor and what became, and, then what came to be known as OpenMBE? And I kind of use View Editor and OpenMBE, interchangeably as terms, but I think we all know the broader context here. So at first it was a little buggy. We had a hard time deploying it. We had a hard time maintaining it. The product crashed. And this is not a knock on the dev team responsible for it by any means. It was more a comment about, the maturity of the solution at such an early stage of its life cycle, as well as, the fact that there were technologies in use that we weren't experienced in and didn't have the expertise to deploy properly in our environment. So it may sound bad at first when I say that, they were buggy, but it was actually fortuitous. And it was fortuitous because it reinforced the message that this was not a competing product. It was not something that at the time had the polish to be used in prime time. But the vision was there and the lessons learned were solid. And there were lessons about modern UI design. And, it was the first time we had seen a fully deployed and documented REST API used in the context of our software. So this wasn't about getting a piece of, open source software and deploying it in our labs. This was about meeting, engaging, discussing, and really seeing how our tools were being adopted in the context of OpenMBE in this environment. We saw how our products were being integrated into this environment, from the modeling repository to the rich client. And it was an eye-opener, it was a real eye-opener, not just to me, but to the whole organization, I think. At least at the management level, I think it was an eye-opener. So, the lessons of that cooperation and the experience of that engagement with the community began to manifest themselves in different areas of the portfolio, not necessarily in the sense of taking open source, source code, but definitely in terms of the technologies used and some of the specific services that we began to develop and some of the capabilities that were being implemented. It really impacted the portfolio in terms of the products and the technologies. And I think that really played well in the market. So what was the direct influence of this cooperation and involvement with OpenMBE? So the first salvo was the development of a document modeling plugin. And the purpose of that plugin was to allow a user to build a model-driven specification for document generation. So, giving a user a capability to design their own document structure and format without needing to know the reporting language or scripting language inside of MagicDraw. So really, eat your own dog food. Here's a model-driven approach to representing the model as a more broadly consumable, model-driven, automatically generated document. But there was more that followed, right? So those lessons directly impacted the introduction of web-based collaboration and document-like views that were automatically generated from the model. REST services were implemented that had been, influenced by MMS, and in some cases there were even similarities with, in underlying technologies such as the use of the Alfresco content management system in the initial releases of Cameo Collaborator. But what I think was the most important result of the work that was done within that OpenMBE community and the engagement we had wasn't so much in the direct impact on the products or the influence on the products. It changed the view that we had as an organization about how to engage with the users and the community. As a result of this engagement, we were very open to furthering our support of the community. And I think that was very noticeable with, when we made this Teamwork Cloud and Cameo Collaborator platform openly available to people wanting to participate and contribute in standards work and the sharing of sample models and the cookbooks, all the stuff that we saw from Robert and Chris earlier in the morning. A lot of that stuff is actually hosted on a platform that we as a software vendor made available to the community because we believed in the community. There was no doubt, in my mind that hosting this modeling platform in this era was a necessary means to show our support of the modeling community. And that as a company, we were interested in measuring our success by more than just the value of each financial transaction. We were changing the way we were measuring our success by how we were being embraced and engaged, and how we engaged with the community. So how did this benefit us and the companies who use our software and the end users directly? Well, the bottom line is that these new products and features came to market in a shorter time frame, and they came to market in a shorter time frame than had we had to develop them completely from the ground up, because some of these capabilities had already been defined with enough specificity in what we were seeing coming out of the OpenMBE community that we were able to implement those capabilities that had been vetted in this shorter time frame. Now, were they implemented exactly as presented in OpenMBE? The answer is no, not for the most part. But as a software, as a software vendor, we had to put our spin on it. We had to add our value from our knowledge and experiences as well, and we had to make them our own so that they would work in the context of the larger vision that we had. But kind of the key here is that I didn't have to expand the R&D team with more developers and analysts to deliver what we did. I didn't have to go to finance and ask for approval for additional headcount and then wait for new staff to get up to speed and then start implementing. The impact is real, right? This means that we can deliver value in a shorter time frame when we engage in a community like this and do a better job of understanding the needs and the use cases and those requirements. And I think as systems engineers, everyone understands how important that is. But what's really exciting about what we were seeing in this community was it wasn't just the use of the technology, but the use of the technology in the context of the development of those practices and modeling standards and approach, and even the beginnings of content that could help accelerate adoption and at the end improve the quality of the work being done in the MBSE community. So we definitely saw the benefits as the commercial success of MBSE really took off. Adoption grew exponentially, and it seemed like almost every major award had a link or some sort of relation to OpenMBE. And these were not always small deployments. In some cases, these were quite large and significant, and either agency or in some cases even enterprise-wide. And we had never seen that type of adoption before, not to that scale, as we were seeing, in these opportunities and acquisitions where OpenMBE was part of the equation. And these spanned industries, from aerospace to automotive and defense, and they weren't focused around a cluster of, communities or a cluster of companies around JPL, in Southern California. These were, really coast to coast within the US. And what was interesting is that it wasn't necessarily experimental either in these organizations. In some cases, it was foundational and instrumental to both the acquisition of the MBSE tooling and the adoption of MBSE within those organizations. So I think that the maturity and focus and effort that was put into the MBSE tooling helped OpenMBE as much as OpenMBE helped mature the tooling and get it to a point where it was seen as a more viable solution for some of these organizations. So how does OpenMBE compare with some other communities? And I know the slide says open communities, but it's really just communities. And it is different. It is different. So the first one, let's look at is OMG. So there's clearly a synergistic relationship between OMG and OpenMBE, but they are different types of organizations, at least in my opinion, and what I see, they're different types of organizations. So OpenMBE has started to focus and has aspects of it on providing best practices and content and so on. And as an organization itself, obviously OpenMBE does not develop standards. It does contribute in the context of OMG, at least the representative organizations that are members of OpenMBE contribute. But OMG has a pretty strong and balanced representation from government and academia and industry, as well as vendors. And OMG has done a really good job at building reciprocity with some other standards bodies. And of course, we all know that that's where UML and SysML and UAF came from. But as I mentioned, OMG is strong on standards, but really not doing much to educate the community on how to best use them and implement them. OASIS, where OSLC and SAML are maintained, slightly more limited membership than what we see over at OMG. It tends to be very large software companies like IBM and Siemens and Dassault Systems, and a few major industry participants like Boeing and Airbus, but really very limited, if any, government or academic membership. And the level of engagement in OASIS varies significantly from project to project, primarily based on who the members are for that project. And then of course there's Apache, right? And this is the granddaddy of all open communities, hundreds of communities supporting hundreds of millions of lines of code, and hundreds of projects. And of course, you want to talk about varying levels of participation and processes and so on. Well, this is it. I mean, if you just go look at the projects, there are dozens that are dead already, but there are dozens that have been highly successful. As an example, Cassandra, came out of the Apache Software Foundation. There are community versions with, limited support, and there are commercial versions, supported by DataStax. So, very successful story there with Cassandra. So all three of these are focused on stewarding some degree of intellectual property, be it, standards or open source code, but they don't provide roadmaps for practitioners on how these building blocks can be implemented in production environments, how to best integrate them, or how to produce the best possible outcome. And in most cases, if you leave this entirely to the vendors, it's not always, what's in the best interest of the broader user community. So none of these that I mentioned are quite like OpenMBE, and I think Robert prefaced this quite well in his opening remarks. OpenMBE is a community of interest centered around model-based engineering and this open and connected model-based engineering. The focus is not on managing source code or developing standards. And what's really interesting is how this community of interest brings together aspects of all of this, from technology to standards, processes, and content, in order to advance the practice model-based engineering and model-based systems engineering. It's a broad community from industry and academia and vendors to show what is and what can be and what is needed for model-based engineering inclusive of MBSE. To be successful, you know, these cookbooks are important. They're needed. Sample models, you know, all of that content really improves the adoption, the onboarding, and the proliferation of high quality modeling and high quality MBSE practices. But what I like about OpenMBE is that it challenges the status quo. Right? It's always looking to see what the next capability is that will benefit the community. We saw that from Chris, right? They're already looking at you know, this global, you know, inter-organizational vision. That's exciting stuff. You know, and what's interesting is how the OpenMBE community approaches this, which is in an open and collaborative way. And this is the closest model I've seen that aligns the interests of all the stakeholders. And if the stakeholders, especially the software vendors, view it in the proper light, I think it's the optimal way for software vendors to engage with customers in a focused community of interest and deliver real value to the community. So, how do I see the future? How do I think this impacts the future of software development? Well, in the context of engineering software, I think companies have to change their business models. And this isn't a question of perpetual versus term-based licensing. I'm not talking about a financial model for commercial transactions. I'm talking about a fundamental change in the way we interact with our customers. The focus needs to be on empowering and enabling the community of users who are our customers. It's about collaborating in ways that benefit everyone. You know, the longer-term relationship will build much more economic value for a software company if we can embrace these communities and foster their growth. The software vendors have to insert themselves into these communities and help them thrive. We have to engage with academia because we still need some help in systems engineering, right? We need that brain power that Robert mentioned to help ground some of the developments that are still to happen with a rigorous and strong scientific foundation. We have to provide content and access to technology to teach the next generation of engineers so that they are ready when they come out to help us solve, you know, the problems that we're facing in a fully connected digital platform. Software companies need to move away from the idea of billing for every single line of code. That is not a fruitful or conducive or productive way of doing business. And we've seen the transition happen in almost every industrial sector. You know, we're seeing companies like IBM and Microsoft embrace open source. And I'm not suggesting that the companies in this industry go that route of becoming open source, but the emphasis needs to be on the value of what we are delivering and how we help enable success in our user communities. So do I envision this as being, you know, a situation where many commercial software companies engage in a single community like OpenMBE? Highly unlikely. There's too much animosity and sense of competition among vendors in a single industry segment, and quite honestly, some see OpenMBE as a threat. So in the short term, at least, we will likely see this continue to play out as it has in the past. Many will sign on, claiming to support it, so they can hang, you know, the badge, you know, on the marketing material. But very few will actively engage, and even fewer will really participate and enable. But the companies who properly integrate this into an overall product management process with active engagement, bidirectional exchange with tight and frequent feedback loops will find that not only are they better leveraging their user community, but they're delivering better products. And those products will be much more closely aligned with the user needs in the market. And if we do that, if we align our products with the user needs and the market and add our creativity and ingenuity to it, we will also benefit from stronger and more consistent revenue streams. So what can the OpenMBE community do? Continue challenging the status quo. Continue showing us what is possible. OpenMBE is helping to shape and push the vision of tomorrow. So go out and find good industry partners, those agile, progressive companies that want to change the game. This is as much about the OpenMBE community embracing your stakeholders as it is about them embracing you. So embrace, engage, empower, and enable. And the companies that are going to be successful in this arena in the future are the ones who really become that trusted partner and part of the community, not just your run-of-the-mill software vendor. So as I promised, this would be around 40 minutes. And if any of you can identify the first DELP, when I said, oops, wrong DELP from slide 5, I will actually go back so you all can see the original DELP. So if anyone can identify him, I will be quite impressed. But thank you so much. I really appreciate the opportunity to present to you all today. If you have any questions, and of course, if you know the first DELP, feel free to contact me. There's my current email address. And if there are any questions, I'm happy to open the floor and answer them.
Thanks a lot, Enrique, for your excellent talk. I think that the chat as well as the questions and answers session should be open to participants. Although I've just received one note that maybe chat is disabled. I mean, I'm writing to chat anyhow. So I'm asking the participants to ask their questions. So questions and answers seems to be disabled. I'm asking Sebastian if chat is open.
The chat is open and the Q&A is supposed to be open too, actually.
Uh-huh.
So, and we've seen there's someone who asked a question about the chat, actually. So the Q&A is working. And I just opened the chat.
So until we resolve these technical glitches, I wonder if Chris or Robert, as the co-hosts of the session, could go forward with asking the first questions while the questions from the larger audience come in. Oops.
No, it was a great presentation, Enrique, and it was great hearing your perspective on that engagement. So I guess one question I might have is what do you think OpenMBE could do as part of that future vision you laid out to realize it from the open source side?
I think you're on your way to doing it already, right? The fact that you have seen this degree of growth in the size of the community itself, you have more contributors now to the community, and I think you guys just need to keep doing what you're doing. It is really the onus, I think, is on the software vendors to realize that the world around us has changed. And, we as engineering software companies can choose to try to entrench ourselves in, the ways of the 1970s and 1980s, or we can follow and eventually take a lead in kind of this new engagement model that we've seen in almost every industry. So, you mentioned the software industry and the benefits that open source software has seen for so many years. And what's interesting is I was on a call several months ago where a very interesting comment was made, and it was by a company that was starting to look at MBSE, and the comment they made was, you know, we manage tremendous complexity in our software environment, right? We want to see that same level of capabilities in the tools that we use to manage and design our hardware solutions. And we need that because the level of complexity on the hardware side is growing and it's becoming unmanageable. And the software side seems to have done that very well already, right? And I think you alluded to that earlier in what you said. So why are we playing catch up with the software community? Let's take the lead. We are involved in the most complex systems in the world. You know, why aren't we as a community setting the path and the direction for that? So as a community, I think OpenMBE, you know, with the level of engagement you have, just keep doing what you're doing. Find those software companies and software vendors who value this, and, you know, continue to grow, right? You know, for lack of a better term. I hope I understood and answered your question properly.
Yeah, thanks.
I have a question, Enrique. Thanks.
Yes,
thanks
Robert.
So, as we mentioned in the beginning, the community is not only about the open source software, but also about kind of open source modeling. How do you think the users could come to embrace open source modeling? What would be to embrace open source modeling in comparison to open source software? How could we get the users to embrace that, to contribute, to commit, to share?
That's a really good question, right? Because we've seen other industries where sharing of content has become, you know, a key to growth, right? So I liken it to kind of my experience with a business intelligence dashboard, right? So I do a lot of work with business intelligence dashboards in what I do, and when the first thing I do when I start building a dashboard is I go to the quote content store for the dashboard, and I see what connections are available, and within the context of those connections, are there any sample dashboards, right? And we're missing that both in the context of the proprietary tools as well as the open source tools. And I think one of the things that you've started to see with that open community that was hosted or is hosted by NoMagic is that there is starting to be some degree of content that is shared there, but the challenge, of course, is that that content is only good for one software platform. So I think one of the things that is necessary to enable that is that there needs to be within the industry a better, more consistent way to share and interoperate models, be they SysML or some other language. Well, and when I say SysML, that's inclusive of SysML2. So that content can be produced by from any authoring tool and consumed in any authoring tool. And I think, you know, if we go to the intent of SysML2, that is one of the intents in SysML2. So there has to be a technical enabler to begin promoting that sharing of content. And hopefully we'll see that in SysML2 or some of the lessons from SysML2.
Thanks a lot, Enrique. We are receiving questions in the Q&A section. Actually received already 3. One is related to one of the benefits of OpenMBE is the blending of open source and proprietary tools. So are open source solutions available for every part of the OpenMBE ecosystem? And what core capabilities in the OpenMBE ecosystem are only brought by vendor proprietary tools? That's let's say first first question. Is there an intention to fill kind of all the gaps with both the vendor-specific and open tools, or this will just evolve?
No, I'll take a crack at answering that. So probably the most, I think, and Enrique kind of just alluded to this, probably the most obvious gap is there isn't an open source SysML modeling tool that at the very least that's of the horsepower of what you might see in the software community. So I think that's the biggest gap. Outside of that, it's not necessarily always going to be feasible to have an open source alternative to what is available in the commercial world. But as we see from the software open source practices, that doesn't always matter. So I think if that needs to happen, then the community will have the groundswell around it to make it happen. And you see that a lot in the Python and Jupyter Notebook space. A lot of math tools that used to be proprietary have sprung up with open source components that I think really emphasize the key things that people do in a broad sense and need to share in a broad sense. So, but I think we do hope to have an open source SysML2 foundational capability at some point that will close that particular gap.
Thanks a lot, Chris. Another question asks about how could we arrive at, let's say, package managers or repositories like NuGet or Maven for models? Any of you willing to take this?
I'll jump on that one as well. I think on OpenMB, I think the discussions around using Conda as the means for that mechanism is the technology we've discussed for it. But I think it's an important capability, and for many of these package management tools, the contents of the package don't seem to be as significant. So I think it's more just about doing the legwork to get the model into that package, and probably more importantly, what does it mean to have a packaged model that can be shared? I know Robert and I have discussed this at length, and a lot of us have discussed it in OpenMB, because it ties heavily into the collaboration. How can I deliver you a versioned model of my part of the system, packaged in a way that you can consume it the way a software developer would consume a library and manage the configuration at that most loosely coupled level, versus right now where SysML models and other models tend to be largely bound in the modeling repository itself. Even within the MMS, it may not always make sense to just have a gargantuan 30-level mounted model that captures everything in a live sense. So it's a great discussion topic.
Another technical question that arrived in the chat asks about is the OpenMB currently using some open source components, maybe from the Eclipse ecosystem, like, I don't know, EMF to save models, or did some specific capabilities require new development, or how's the mix of using open source versus new developments happened in, let's say, in the last couple of years? How much did you have to throw out and build up totally from scratch? Maybe compared to the kind of tools that we had 5+ years ago, or the kind of open source that you build on was more like general open source software, like you mentioned with respect to Jupyter Notebook and the like.
So the MMS started very simple, and I think the focus was really to emphasize it being built as a native application to the internet. So it focused much more heavily on web-based technology and interoperability than it did on pulling in existing modeling capabilities. So I know that that continues to be a source of discussion as to how some of those capabilities can be added. And I know there are some modeling clients that use Eclipse that have built integrations to the MMS on the client side. But having the intersection between a web native application stack and having the application specifics around modeling languages is an exciting challenge, actually, I think, to move in that direction. And a lot of languages are looking at how they integrate with web services. So I see no issue with compatibility there, but it hasn't been done yet as far as the core model management service.
I have one question specifically to Enrique, because this was one of the final slides of his talk. So how do you see the more efficient involvement of academy, given that the pace in which OpenMBE has been evolving is much faster than typical academic pace, where, let's say, the time frame of graduating a PhD student is 3 to 4 plus years, where if I look back to, let's say, 4 years in the past, OpenMBE was, let's say, very much at its infancy. Any ideas on how to bridge this sort of gap with respect to timelines to get more efficient involvement of academy?
Academia just needs to go faster. I'm just kidding. You know, that's a good question. And I think the necessity in that, or the approach, is not just a purely academic one, right? It relates to how academia and industry work together. So I don't know that I have a definitive answer for you, but I think getting academia engaged in aspects of OpenMBE and the modeling community where there are still foundational gaps is really important. And in that respect, I don't know that aligning the time frame is as necessary as ensuring that the quality of the work that's coming out of academia properly grounds those approaches properly in systems engineering. Like, you know, one of the things that I see as potentially happening or a necessity is that we may have to look at reasoning in the models, right? Is one of the benefits, reasoning from the models. Is that being done in an optimal way? Are the languages properly aligned for the reasoning engines that we have? And as we get new languages like SysML2, how quickly can we adopt those so that we're getting true, good truth out of the models and ensuring consistency in the models? So I don't think it's necessarily about ensuring that academia can work at the pace of OpenMBE or any open source project. It's about ensuring that where it is engaged properly, deeply, right? Because I think if it's engaged properly and deeply, by nature, there will be a balance of pace that will occur between the need in industry and the pace at which academia can go. So I think one's going to pull one a little faster and the other one's going to slow them down a little bit, but we'll reach a nice steady state.
Thanks a lot again for Enrique for taking the role as a keynote speaker. Thanks a lot also for Chris and Robert in organizing industry, let's say the OpenMBE Day as part of the Industry Days. And I was kind of warned by the organizers that we have to try to adhere to the scheduling of sessions as precisely as possible. So I suggest that we stop now and we continue at 11 a.m. local time, so 28 minutes from now, with the technical sessions of the OpenMBE Day. Thanks a lot again, Enrica. Let's say a virtual applause.
Thank you.
In this remote setting, and let's meet all of you hopefully at 11 a.m. Which is 27 minutes from now.
Thank you very much.
Thanks a lot again.